switch over to the next number 45th problem. In the case of Huygens eyepiece, the ratio of focal length of islands, effective focal length and length of the eyepiece is how much? Three values he is asking. Ratio of what? Focal length of islands, the first one. Effective focal length, the second one. Length of the eyepiece, the third one. Options are given this way: 1:2:3, 2:3:4. Third option 2:1:3, and fourth option 3:2:4. What is the correct option? We have to decide. Like in the previous case, we have to first of all recollect what are these values of which the ratio is asked in this problem. Focal length of islands, you can write directly this way: focal length of islands. Just recollect once again, in the case of Huygens eyepiece, field lengths and islands, they differ in their focal lengths in the ratio 3:1. If focal length of islands is f, focal length of field lengths will be 3f. But here he is asking islands only, therefore I have written it as f. That is the first value he is asking in that ratio. What is the second one? Effective focal length. So let us write what is its formula now. Effective focal length. In the case of Ramsden's eyepiece, effective focal length is 3f/4 in the previous problem we have come across. Now effective focal length in the case of Huygens eyepiece, it is 3f/2. What is this 3f/2? How to remember this one? It is either focal length of the field lengths by 2 or 3/2 times the focal length of the islands. Either that way you can remember or this way you can remember, it is left to you. Focal length of the field lengths is 3f. Therefore, focal length of field lengths by 2 or 3/2 times the focal length of its islands. That way also you can remember. And what next he is asking? Length of the eyepiece. Length of the eyepiece, if you write length of the eyepiece, it's nothing other than the distance of separation between field lengths and the islands. In the case of Ramsden's eyepiece, it is 2f/3. In the case of Huygens eyepiece, it is simply 2f. So three values he is giving us in the problem for which the ratio is to be calculated. So what will now be the ratio, please? F is to 3f/2 is to 2f. That is the ratio what he is asking us to write. This now can be written as 1:3/2 is to 2. So directly you can write it is 2:3:2. Check that ratio 2:3:4. Which option is now given over there? First option 1:2:3. Second option 2:3:4. It's very clearly given there. The second option is tallying with the calculated value. So we can say the answer for this one as simply B. Once again, just to check these three values. Focal length of islands, f. Suppose if they ask you field lengths, it will be 3f. Effective focal length, standard formula 3f/2. And length of the eyepiece, standard value, it is 2f. In fact, what is the 2f over there? It is the distance which is equal to the difference of the focal lengths of field lengths and islands. Field lengths focal length 3f, focal length of islands f, the difference is equal to 2f. In other words, you can remember this distance is equal to the average of the focal lengths of field lengths and islands as well. Average in this case f it is, and 3f that one, 3f plus f/2, you will be getting 2f. In fact, these two are the conditions to minimize spherical and chromatic aberrations respectively. Average, if the distance of separation is equal to the average of the focal lengths of field lengths and islands, then you can minimize chromatic aberration. If it is equal to the difference between the focal lengths, then you can minimize spherical aberration. So both the aberrations are minimized in this particular eyepiece, that is Huygens eyepiece as such. This is problem number 45 what we have. Check the next number 46. If the effective focal length of Huygens eyepiece is FH, then the length of the eyepiece is how much? First option is given 3 times FH divided by 4. Second option is given 4 FH by 3. Third option is given 2 FH by 3. And fourth option is given 3 FH by 2. So what is the correct option? We just have to decide out of them. See, that is problem 46 I am talking about. Length of Huygens eyepiece is given as FH. Length we just want. Length of Huygens eyepiece, that is given FH. What is its value officially? It's simply 2F. In the previous problem also we have taken this formula. Now what is this question? The focal length of Huygens eyepiece is given. So focal length of Huygens eyepiece, that is effective focal length. What is effective focal length of Huygens eyepiece here? Effective focal length of Huygens eyepiece is going to be 3F by 2. That value is given as FH in this problem. It's not simply length. Focal length of Huygens eyepiece is given FH. And what the question is asking? What is length of Huygens eyepiece? That is the one. Length actually is 2F. We know that formula. Therefore, from this what we can write now? F is equal to 2FH by 3. Come on, bring that one and substitute it here. Twice 2FH by 3. So how much it will now be? 4 times FH by 3. That is the calculation. So 4 times FH by 3, that answer is coinciding with the second option in this given problem. Therefore, answer becomes B for this problem 46 now. That is the case. One is focal length given, length is asked. Focal length formula is 2F by 3, that is 3F by 2, and length formula is simply 2F. Just convert and finalize your answer. That is problem 46 for us. Check the next number, that is problem number 47. If the focal length of field length is 4.5 centimeter, then the equivalent focal length of Huygens eyepiece is how much? Options are given 2.25 centimeter as the first option, 1.5 centimeter as the second option, 3 centimeter as the third option, and 2.5 centimeter as the fourth option as such. First and foremost, he has given focal length of field length as 4.5. Let us write that value. Focal length of field length. That value is given 4.5 centimeter. That is the only value he has given. And what is his question? Equivalent focal length of Huygens eyepiece. Recollect once again. Equivalent focal length. Right. Of which eyepiece? Huygens eyepiece. Equivalent focal length or effective focal length, whatever you talk about, in the case of Huygens eyepiece, it is 3F by 2. Just recollect once again what is the formula for focal length of field lens. Formula in the sense what? Field lens, the focal length of that one will be 3 times the focal length of eye lens. So, can't you just understand this itself is equal to 3f? So, 3f is 4.5 means 4.5 by 2 must now be the equivalent focal length. So, how much it should now be? 2.25 centimeter. So, the effective or equivalent focal length of Huygens eyepiece is 3f by 2. And we know 3f is focal length of the field lens, which is given there as 4.5 centimeter. So, the moment you know that value given over there is 3f, simply write that 3f as 4.5 by 2, which now gives you 2.25 centimeter. Thereby, the answer, the correct option for this one is A itself, because the first option only is given 2.25, second option 1.5 centimeter, third option 3 centimeter, and fourth one 2.5 centimeter. So, correct option now is first one, which is 2.25 centimeter as such. So, this is problem number 47. Look at the next number, that is problem 48. In Ramsden's eyepiece, the two plano-convex lenses, each of focal length f, are separated by a distance of 12 centimeter. Separated by a distance of 12 centimeter, can't you understand the distance between the two lenses taken in Ramsden's eyepiece? Is it not called length of Ramsden's eyepiece? So, what is going to be that length formula? 2f by 3, that is the distance of separation between field lens and eye lens in the case of Ramsden's eyepiece. Then what is this question? The equivalent focal length of the eyepiece is how much? So, you can understand first of all length that is given. What is that length by formula? 2f by 3, that is given as 12 centimeter in the problem. Distance gap between the lenses in Ramsden's eyepiece, that is field lens and eye lens, they are separated by a distance of 2f by 3, that is known to all of us. So, the 2f by 3 is given 12 centimeter. Then what else he is asking? Equivalent focal length of this eyepiece. Equivalent focal length, how much it is going to be? 3f by 4. So, first of all you write this one, f will now become, right, 18 centimeter. So, write that value 3 times 18 by 4. Okay, you can take this one 927 by 2, which now becomes 13.5 centimeter. So, what is the correct option over here? You can directly decide equivalent focal length is how much. First option is given 10.5 centimeter, second option is given 12 centimeter, third one is given 13.5 centimeter, and fourth one is given 15.5 centimeter. So, what is the correct option? You can decide right now. It is the third option that is going to be correct out of it. So, equivalent focal length is 3f by 4 in Ramsden's eyepiece, 3f by 2 in Huygens eyepiece. This comparison, if you have in memory, such models can be worked out easily. So, if we look at this 49th problem, a small telescope has an objective lens of focal length 140 centimeter and eyepiece of focal length 5 centimeter. The telescope is used to view a 100-meter tall tower 3 kilometer away. The height of the image of the tower formed by the objective lens is nearly how much? The height of the image of the tower formed by the objective. That is the concept. So, what exactly you should understand in this case is, focal length of objective is given, it's 140 centimeter. Focal length of eyepiece also is given, That value is provided to us as 5 centimeter. These two are the values firstly he has mentioned. Fine. What next he has given? There is a tower of height 100 meter. That is height of the tower. That I take this one as the height of the object, because tower itself is the object for us in this problem given. And where is it located? Distance to the tower. Distance to the tower, that is given as 3 kilometer. So this is what actually is talking about as far as objective that is concerned, because the distance is measured directly from the first lens, which of course is the objective in this particular case. So the object, which is the tower, is of height 100 meter and is at a distance of 3 kilometer. Now his question is the height of the image of the tower formed by the objective lens is nearly how much? So first and foremost, take this value. Distance to this tower means I can write this one as object distance with respect to the objective. Now taking these two, you first of all estimate what is the image distance from that objective. So what we can understand in this case roughly 1 by UO plus 1 by VO is equal to 1 by FO. We can directly write this formula UO for object distance and VO for image distance and FO for the focal length of this objective. So we now can write roughly 1 by VO is equal to 1 by FO minus 1 by UO. You can rewrite the same UO minus FO by UO FO. I can take the image distance VO as UO FO by UO minus FO. UO is 3 kilometer, right? 3 kilometer, 3000 meters. But here is the FO value is given in centimeter like. So roughly we can say this one into 10 to the power 2 meter to centimeter by 3 into 10 to the power 5 minus FO, that is 140 centimeter. You can definitely understand this 3 kilometer when comparing to 140 centimeter is too very much. So roughly you can estimate your answer. What is that roughness over here? When object is very far from this objective, where will be the image formed? Image will be formed at its focus. That means image distance automatically becomes focal length. So you can directly understand in this particular case, image distance, this is nearly equal to the focal length of object. That means what? You need not take this one because this value is going to be very close to the focus. So directly image distance you can go ahead for, that is focal length. Now recollect what is magnifying power. It is image distance by object distance, which now is equal to height of the image formed by height of the object considered. And we know pretty well what is this VO now equals to? FO by UO is equal to height of the image by height of the object. Now his question is, what is the height of the image? That is the question. So what is FO now? You take 140 into height of the object. Height of the object, that is given 100 meter. So in 10 square centimeter you can write. By UO, what is the object distance he has given you? 3000 into 10 square. Now cut these two values. Cut these 3 zeros over here. So what is now left over roughly? 14 by 3, that is left. So you can understand the height of the image is going to be around 14 by 3 centimeter, nearly. That is what he is asking. So if you just look at this calculation carefully, you need not work out this calculation. Looking at this value of 140 centimeter, this value which is 3 kilometer, 3 into 10 to the power 5, when comparing to that one, 140 centimeter is meager. If that is the case, object distance can be taken as infinity like. Then where do you find the image now? Yet its focus will be finding the image. So considering that concept, directly go ahead this way. So this VO now can be written as FO, and equating the values and substituting the numbers there, you will be getting 14 by 3 centimeter, which exactly is the very first option which has been provided to us in the problem. So problem 49 now has got the first option as 14 by 3 centimeter. Only point you should recollect is, when object is very far from the lens, the two convex lens, image distance is going to be very close to focal length. Very close to focal length. So automatically and roughly we can take the image distance as focal length itself. That is the point. So this is problem 49. Problem 50 says that the diameter of moon is 3.5 into 10 cube kilometer, and its distance from earth to that moon, of course, distance from earth is 3.8 into 10 power 5 kilometer. The focal length of objective lens and eyepiece of a telescope are 400 centimeter and 10 centimeter respectively. When viewed through the telescope, the diameter of the image of the moon will appear as how much? Nearly how much? That is the concept. So once again, diameter he is asking, fine. But he is just asking the answers in degrees like. So you should understand here the angular width of the image he is asking. The angular width. That is nothing other than angle subtended by the image at the eye. What is that angle? That is what he is asking us to calculate. So what we should understand first of all is, diameter of the moon is given. Diameter of the moon. He gave this value as 3.5 into 10 cube kilometer. And of course, distance to the moon also is given. Distance to the moon from the earth. That is what has been given there. It's given 3.8 into 10 cube, 10 to the power 5, 3.8 into 10 power 5 kilometer. That's what has been given, fine. Focal length of objective is given 400 centimeter and that of eyepiece is given 10 centimeter. So write once again this 400 centimeter and focal length of eyepiece as 10 centimeter. And certainly one should understand this should be a telescope, because telescope only is used to observe the distant objects, that too heavenly bodies. Astronomical telescope it is. When viewed through the telescope, the diameter of the image of the moon will appear as how much? That is the concept. So first of all, you can understand here, magnification is equal to FO by FE. That is true. Is equal to tan beta by tan alpha. I have already told you this point earlier. This now can be written as beta by alpha also when alpha and beta are very small. But I write this one beta by what will be tan alpha. When you consider this is the objective I am talking, the first lens having focal length FO, object at infinity, then we can all understand this is alpha what it is making, the angle made by the object at the center of the objective. Then tan alpha, is it not opposite by adjacent place? What is opposite side there? Opposite side is nothing other than the size of the object. Size of the object in this particular case has been given as a diameter of the object. That is diameter of the moon. That's what has been given. Therefore, I can write tan alpha as diameter of the moon divided by distance to the moon. Observe this particular concept carefully. Beta by alpha I should write. That tan alpha, which is nothing other than diameter of the moon by the distance to the moon, that I am writing it here. And now I want the value of beta. Come on, equate these two. Then beta is equal to FO by FE into diameter divided by distance. FO is given 400, FE is given 10. Diameter is given 3.5 into 10 cube and distance is given 3.8 into 10 power 5. Fine. But you will be getting this value in radian. This value you will be getting in radian. What we want? We want the value in degrees because options are given in degrees. Therefore, once again, what is the conversion we people have to take? This pi radian, that is equal to 180 degrees. So many radians, how many degrees? So into 180 by pi. So directly write down the same thing here. This now becomes 400 by 10 into 3.5 into 10 cube by 3.8 into 10 power 5. This into 180 by pi, right? You get in degrees. This calculation, if you simplify this total lot, that comes to be very, very close to 20 degrees. So your answer now will be 20 degrees. So what is the 20 degrees correctly in this problem? First option is given 2 degrees, second option 20 degrees, third option 50 degrees and fourth option 40 degrees. So the correct answer for this one is now going to be the second option, which is 20 degrees. Only thing you should understand in this particular calculation, you will be getting the SI unit of that angle. Officially SI unit is radian. Degree of course we can convert, that is a different issue. But officially we get in radian, that you convert it into degrees, then your answer is going to become simply 20 degrees nearly. So that is the correct option for this 50th problem. So one of the excellent models we have. Only thing is tan alpha we are converting in terms of the height and distance. That is the concept. So the correct option for this one is B. That is problem number 50. Problem 51. One of the important most concepts, that is deviation without dispersion concept. I read out the question given first of all. A crown glass prism of angle 5 degree is to be combined with a flint glass prism in such a way that the dispersion is 0. The refractive indices for violet and red lights are 1.523 and 1.514 respectively for crown glass prism, and flint glass are 1.632 and 1.614. The angle of flint glass prism is how much? 4 options are given: 10 degrees the first option, 2.5 degrees the second, 2 degrees the third, and 5.45 degrees the fourth option. One should understand first of all what is that condition he is mentioning there. Dispersion should be 0. Whenever light is entering into a glass prism, particularly white light I am talking, you will be finding dispersion as well as a deviation in the system. White light splits into 7 of its colors, constituent colors we know as C.V.R. In addition to that, each color used to even have deviation also. That means inside the prism, whenever white light is entering into the glass prism, both dispersion and deviation are going to be observed. But here particularly he is asking as a condition. He don't want dispersion to take place inside. Dispersion is 0. That means what? Deviation should be there, but not the dispersion. So deviation without dispersion condition we have to take. I write that one here. Deviation we should have without dispersion. That is the condition. What is the condition for that? For deviation without dispersion, A by A dash. A is the angle of the first prism, like crown glass prism. A dash is the angle of the flint glass prism. A by A dash is equal to mu V dash minus mu R dash by mu V minus mu R, whole with a negative sign. And first thing you should understand the importance of this negative sign. Negative sign indicates that both the prisms are to be attached in the reverse order. Means what? If one prism is taken this way, the second prism is supposed to be attached this way. One is reversely attached to the other. That condition is given by this negative sign. And second point, mu is refractive index. Mu V is refractive index for violet color in the first prism, mu R for red color in the same first prism. Mu V dash and mu R dash, they are the refractive indices for violet and red in the case of the second prism taken up. So let us write now this one. A, I am taking it as the angle for the crown glass prism, and A dash, that is for flint glass prism. So crown glass, how much he has given? 5 degree by A dash. Fine. Now mu V dash minus mu R dash, they are for the flint glass we have to consider. For flint glass, what are the values given? 1.632 minus 1.614. That is the pair of values given for flint glass, one for refractive index for violet and one for refractive index for red. What about the other pair he has given? 1.532, that is 523, that's one value, 1.514. 523, 1.514. Totally with a negative sign we people used to write. Now what is the difference of these two? First of all, you see this now becomes 8 over here and of course 1 over here, 0. 0.018. and this is 14 and this one is 23. So definitely you can write 0.009, that is for the denominator. So when you write it like this you will be getting exactly 2. No doubt with a negative sign. Negative sign only indicates how to attach the prisms. I have already told you that point in the beginning itself. Now we just want the value of A dash. It now should be 5 over 2, which now is 2.5 degrees with a negative sign. So 2.5 degree is the correct answer for us for the angle of the second prism, that is flint glass prism, when we consider deviation without dispersion. So the options are given this way. First option is given 10 degrees, second option is given 2.5 degrees, third option is 2 degrees, and fourth option is 5.45 degrees. So what is the correct option now for us? It should be the second option. That is the correct one. But I repeat once again, this negative sign doesn't come into picture officially. It only gives you that you have to attach the prisms in the reverse order like that. That is the concept. So this is problem number 51, one of the best models what we are having here.